Okay, today we're doing present value of an annuity, which is very similar to yesterday's stuff. The only major difference is our formula is going to be a little different because we're not talking about the future value of interest or an annuity. We're talking about the other way around. And usually what that means is when you take out loans. So this is pretty applicable to what you guys are going to see in the future. For our first question, Manny has decided to purchase a $2.5 million home. He's able to obtain a mortgage of 3% annual interest rate. In Canada, mortgages can only be compounded semi-annually at max. Okay, this part's important. This is the confusing part. It will be a 30-year mortgage. Manny needs to put down 5% of the value in order to get this mortgage. He wants to figure out what his monthly payments will be. So, this is a very in-depth question. A lot of things going on. It says Manny needs to put down 5%. So we need to figure out 5% of 2.5 million. Is it 75,000?
Oh wait, no.
0.05. I think it's more. Yeah, 100. Wow, $125,000 down. So, what does it mean to put a down payment of $125,000?
You have to give that much at the beginning.
Yes. So this Manny has to give in $125,000 into this $2.5 million home. Now, if that's the case, what is his mortgage going to be for? Will it be a $2.5 million mortgage?
No, we subtract that from
2.5. That's right. Because he's putting a down payment of $125,000, the house that's worth $2.5 million is a ridiculous amount of money. He's actually got to subtract $125,000 from that amount. Otherwise, he won't even be able to obtain this loan, which is commonplace. If you don't put a large enough down payment, they either give you larger interest rates or they won't give you the loan at all. So we take our $2.5 million and subtract $125,000. And his mortgage is for $2,375,000. Still a pretty large mortgage, okay? Now, the formula we're going to be using, and we'll talk about this, because he's taking the mortgage right now, what that means is he has $2.5 million in his hands right now. In other words, that's the present value of the money. Okay? Yesterday we were talking about saving up for a future date. When you retired, when you go to school, something like that, we wanted to save a certain amount of money for a future date. Today we're talking about having that money today. And that's the $2.5 million. When we have the money right now and we're trying to pay it off, something like that, that's the present value formula. So I'm going to bring this down. And it's a little different from the formula we used yesterday. If you guys notice, some of the numbers are kind of different orders here. The variables are the same. Exactly. So n, our power, is a negative. And instead of being 1 plus I, subtract 1, it's 1 subtract 1 plus I. Okay. It just helps solve for the amount in today's terms rather than in the future. Okay. So the present value. What would the present value be right now? Yeah, because we got to subtract that down payment. That's our present value. Present value is $2,375,000. What is Manny trying to figure out?
How much I put in to begin with.
Yeah. Well, you've already figured out how much to put in to begin with. He's trying to figure out his monthly payments. That's right. He wants to know what his monthly payments are going to be. And what that means is he's trying to solve for R in this question. R stands for the regular payments. His are going to be monthly, which most mortgages are. So he's got to figure out his regular payments here. Okay, there's a couple other ones we got to figure out. First of all, what does I stand for?
I over C or whatever. R over C.
R over C. And what is R and what is C?
The rate and the commission.
All right, so that's right. The compound period and the rate of interest.
Commission.
So, the rate of interest is 3%. Now, this was the important part. This is what makes it confusing. What's the compound period of this mortgage?
2.
Semi-annually. Okay? Semi-annually at max. So the compound period is going to be 2. And the interest rate, we got to put it as a decimal.
0.03.
0.03. Compound period will be 2. So our I value.
0.015.
That's right. Good. That will be our I. Our N, still same idea as before. The only difference, N is years times compound periods.
Sorry. So 3 times 12. Where did 2 come from?
The 2 is our compound period because it's semi-annually, which means twice a year. That means we're getting charged interest twice a year, so we replace C with 2. So in this case, C will still be the number 2. We're just using it in another formula here. So our C is still 2. Okay. And how many years was this mortgage?
3.
Not 3.
30.
30. This is a 30-year mortgage, which makes sense. A lot of mortgages are built to be 30-year mortgages. So, N is going to be equal to 30 times 2. How many times do we get charged interest over the life of this mortgage? 60 times. Okay. So, what we've now figured out is we figured out present value. We know we're solving for R. We have values for I and N. We need to plug it in. But I do want to talk about one thing. Remember, this is the part that may get confusing to some of you guys. We're trying to figure out Manny's monthly payments. Okay? And we talked about this yesterday, so I'm just going to quickly do another timeline. Remember when we were doing a timeline yesterday? If it's semi-annually, just for argument's sake, we're going to say we start in January. Okay?
June.
Yes, that's right. So in January, he gets the mortgage. If it's semi-annually, that means he gets charged interest in June. And then again in December, or end of December, or beginning of January, technically. He gets in those same 2 months every year. But Manny's trying to figure out monthly payments. Okay? So what that means is 1, 2, 4, 5, 6. At the end, once we calculate what the actual R is, we're going to have to break that down again. Okay? We're going to talk about that at the end one more time, but let's actually go into the formula now. So our formula here, our present value is actually 2,375,000 is equal to R, we're trying to solve. 1 subtract 1 plus 0.015 to the power of negative 60. Divided by, I should be using the other one. Yep. Or 0.015. Okay. Now, our goal here is to isolate for R. Okay. Our goal is to isolate for this R here. So, I can do reverse BEDMAS. What do I want to move to the other side to start?
0.015.
That's right. And when I move it over, what operation?
Multiplication.
Multiplication. So we take this amount, I already have it up here, times 0.015 equals 35,625 is equal to our regular payments. 1 subtract, and I'm going to simplify that too. That's going to be 1.015 to the power of negative 60. Okay? So, when we do this, make sure you put negative in your calculator. We're going to simplify these brackets here. So we have 1.015 to the power of 60, and I have to make sure it's negative 60. It's going to be very important. It's going to change our number. Instead of making a number that's larger, we're actually going to make a number that's smaller. Okay? So, our number here is, we'll rewrite the next line, 35,625 R 1 subtract, and this is what our bracket is now, 0.40929. That's good enough. Okay. We're going to simplify this bracket. I need to subtract subtract that from 1. 1 subtract 0.4092. Whoops. Nuts. Did we do that? 1 subtract 0.40929.
So it was fine the other way.
Yeah, it was like the rounded version.
9.
Yeah, it was very close. Okay, so our bracket now reads 0.59071. 35,000.
Divide by 0.5.
Okay, so now when we bring over our 0.59071, we divide both sides by it. So these are going to be the payments. We do need to make sense of this, okay? So 35,625 divided by, what was it, Nick?
60,300.
Yeah, okay. So 60,308 and 78 cents. We'll put it in there because they'll charge you the pennies at the bank. Is equal to R. So, are Manny's monthly payments $60,000?
Nope, that's semi-annual.
Semi-annually, very good. So, every June or every 6 months he owns this. How do I break this into monthly payments? We're going to divide by 6 because this is only a sixth of the year. So we take this number, we divide it by 6, and Manny's monthly payments are still very high, but that's because he's got such a big house. $10,000, $10,051.46. If he wants to own this $2.5 million home and take out such a large mortgage.
So his down payment is as much as his yearly payment?
His down payment is as much as his yearly payments, yes, pretty much. Okay, Nick has won the Cash for Life lottery. He has a choice of accepting 4,000. Oh, I forgot to change that part. Ah, jeez.
How you put it?
Now we're back to 1,000 a week. That's the real Cash for Life. 1,000 a week. Okay? So he has a choice of accepting $1,000 a week for 25 years, or he can take a lump sum of $500,000 right now. Nick has been assured by the bank he can get a bank account that will receive 5% annually compounded weekly. Okay? So the good part about this question is our payments are per week and our compound period is per week. So there's no extra calculation at the end we have to do. Whatever we find will be the answer we're looking for. What we need to do, though, is we need to figure out if the weekly payments of $1,000 are essentially worth the present value of $500,000. Okay? So we take this present value formula. Okay? And what we're saying is our R here in this question, or our regular payments, I think we did it in red last time, are $1,000 a week, right? So you get $1,000 every week. Because it's weekly, that's our compound period. So C is going to equal what? 52. There's 52 weeks in a year. Make sure you guys know that. Okay? C equals 52. Okay. We have our regular payments at 1,000. C is 52. Our interest rate.
0.05.
Yeah. Our R is 0.05. So we're going to calculate I on the side. I is 0.05, divided by 52. It's going to give us what?
9,000.
Oh, very small number, so let's put it in here. 0.123. There we go. There's our I. N is the number of years. How many years are we? 25. How many compound periods? 25 times 52. Yeah. 1,300. So there are 1,300 weeks in 25 years. So that's going to be our N, or our exponent in this question. So we go to solve this question. We're looking for what this would be in terms of present value. What would that be worth right now? You get paid for 25 years, $1,000 a week. So we get $1,000 as our regular payments.
1 plus.
1 minus 1 plus, it's a very small number, 2, 3, to the power of negative 1,300. It didn't quite fit, but. And then all divided by that decimal once again, which is 0. And there's 3 zeros, 961. Okay. So we actually need to just solve this question We're going to go through this formula. So, according to BedMaster, we deal with brackets first. So I'm going to simplify my bracket. I have 1,000 on the outside. 1 subtract 1.000961 to the power of 1,300. All divided by we're going to put this to a power now. 1.123961 to the power of 1,300. Oh, going to give us a pretty good number. Oh, sorry. Negative. Thank you. Thank you very much. 1.000961 to the power of negative 1,300. All right. Gives us this number here. So we get 1,000. 1 subtract 0.28687 is good enough for now. Still all divided by 961. We subtract this. 1 subtract 0.2 0.7. 1,000 times 0.71313 still divided by. We take this value, multiply it by 1,000, gives us 713. It's going to be interesting to see what we're going to get. 713.13 divided by this decimal, because this is a really small decimal, divided by 0.000961. The present value would be $742,070.75. So what that means is that in terms of the equivalency, because we have a bank account where if I were to receive $1,000 a week, I could technically put it into that bank account, earn 5% interest, and that $1,000 a week would be like an annuity. Okay? So what we're saying is every week, instead of spending that $1,000, which I know for Cash for Life you most likely would like to, but just in terms of the equivalency, in terms of money, you can actually take that money, make it an annuity, put it in every single week and earn interest. And the present value of that would be $742,000. So what they're offering you as a lump sum, not enough money. Okay? You wouldn't want to take this. It's more in your interest to take that money and invest it. Now, I understand you may not invest it.
Couldn't you take the $500,000 and invest it in for 5%?
And it won't surpass what you would get as a annuity of $1,000 a week.
After 25 years, it won't be more than 700.
Well, think of it like this. Your $500,000 is not an annuity. Your $500,000, you're not going to get any more money. It's just going to get compound interest. So I take $500,000, I just throw it in there, I earn compound interest on it. The $1,000, I get $1,000 a week, and I'm going to get interest on it. So I'm going to put $1,000. By the time we get to 25 years, we're probably up and towards $1 million odd in terms of our payoff, plus we're earning interest. So it'll start off slower, but by the end of 25 years, that $1,000 a week will have earned much more money than just taking $500,000 right now and sticking it in the bank.
The whole thing is once a week.
That's very true. Who knows?